So far, we have looked at the big items of the stack information and condition module. Let's design the simple example together, and I will explain the specific functions in detail. Please look at the workflow of simulation settings. At first, create a project and define a structure in the stack list. After that, set properties of each layer and then set the output condition. Lastly, save the project file and click the Run button. So the first thing to do is creating a new project file. Click this New Project button or click File and select New. Enter the name of a project and set the saved path. I will enter the name as EX1 and save it to the desktop. When Create Project folder is checked, the same folder as the project name is created, and the project file is saved in that folder. In this case, I will check. Please click OK button. From now on, let's define the structure. Please drag and drop the all layers to be used. I will define the structure from bottom to the top. If all layers have been defined in the stack list, let's check the properties from the layer at the bottom. Click on the bottom layer, Aluminum. In Layer Properties, you can check the name and thickness information. Let's change the thickness. The thickness of aluminum layer is 100 nanometers, so I will change it as 100. In Optical Properties, you can enter the refractive index value or set it as an incoherent layer. Additionally, only for the metal layer, you can set the reflectivity. I already mentioned about it in the DB information module, but the reflectivity can be also set in the stack information and condition module. The metal layer can be used as the reflector. So for the reflectivity, enter the value between 0 and 1. For example, if the reflectivity is 0, the incident light is absorbed. Moreover, if you input 0.5, it means that the extinction rate is 50% and the reflection rate is also 50%. In this training, I will use the default value 0. Next is the incoherent layer. Usually, I recommend that a thick optical film or a substrate should be set as an incoherent layer. About this function, please check the Option and Server tab. And here are the source properties. This item is only activated when you add the emitter of the layer. So I will talk about it later on. And let's move on to the next layer, ETL. The thickness of ETL and HTL should be set from 20 to 100 nanometers in 20 nanometer intervals. When setting multiple variables, variable and link options are used. You may have already figured it out. There are red and blue arrows. Red arrow can only select values from the list. On the other hand, blue arrow means that you can utilize the variable function. First, set the thickness of ETL to variable, and then click the variable tab. And I will tell you how to enter the multiple variables. When entering multiple values, separate them with comma or semicolon. And in the case of range condition, enter it in the following form. So for the ETL thickness, the initial value is 20, the final value is 100, and it is 20 nanometer step. So please enter like this. For other options, I will use the default. Next up is EML. First, let's change the thickness. The thickness of EML is 30 nanometers. So I will change it as 30. Also, in the simulation conditions, there is light source information of EML. By adding an emitter, the efficiency and light emission characteristics of OLED devices can be checked. There are two ways to define an emitter. It is divided into either defining a unit source with an intensity of 1 or defining a particular light source dB with emitter characteristics. In this example, for emitter, unit source is used. A unit source is easily added by double-clicking the source icon, like this. Alternatively, when you want to define an emitter with specific light source dB characteristics, just select the light source dB and drag it to the source icon, like this. Since it needs to be set as a unit source in this example, so please double-click the source icon. You can see that source properties are activated. And for the layer where you put the source icon, please set the imaginary part as 0. So I will change it as 0. In addition, the refractive index of EML should be set as 1.769. So I will change it as this constant. And then let's check the source properties in detail. Please look at this part. In the source, light source information such as path or name will be displayed. And choose the dipole position type, height, or ratio. When selecting height, set the point of light emission as a position. In this example, the thickness of EML is 30 nanometers. So if I enter the position as 15, it means that light emission occurs in the center of the layer. Therefore, when selecting the height, you should input the dipole position based on the thickness of the layer. With a similar concept, when the ratio is selected, the point at which light emission occurs can be set within the range from 0 to 1. For example, 0 means that light emission occurs at the bottom of the layer, and 1 means that the light emission occurs at the top. In this case, I will just use the default setting. After that, select the dipole orientation method. It can be mainly divided into 3 types: about user-defined 1, about user-defined 2, and polarization. Isotropic, horizontal, and vertical are related to the following user-defined 1 formula. When the theta is 0.333, it is isotropic. When theta is 0, it is horizontal. And when theta is 1, it is vertical. If you want to enter the theta factor directly, choose user-defined 1 and then input the theta factors. And the next one is about user-defined 2. TM, TE are related to the user-defined 2 formula. In this case, you need to enter 3 terms: TM vertical, TM horizontal, and TE horizontal. As the same way, if you want to enter the theta factors directly, choose user-defined 2 and input the theta factors. Finally, polarization is used when setting a light source with polarization components. Enter values for EX, EY, and phase. In this example, for the dipole orientation, select user-defined 1 and check the 3 values for the theta factor. Therefore, by using the variable function, I will set this condition. Please select user-defined 1, and for the theta factor, I will select variable and click the variable tab. And I will enter like this. The next one is EQE parameter. Input the values for the parameters to calculate the external quantum efficiency. Since radiative efficiency and outcoupling efficiency are calculated by the simulation, just enter the electrical efficiency and quantum yield. In this example, I will use the default setting. And the next one is HTL. Like ETL, HTL thickness should be selected as variable because the initial value is 20 and the final value is 100 and it is 20 nanometer step. It is totally the same as ETL thickness condition. So, for the thickness, please select as variable and click this variable tab. The condition is the same as ETL thickness, so just copy and paste it. And then I will talk about the link option. It is an advanced function of the variable. Two or more variable conditions can be linked together. I will show you an example. First of all, without the link option, two variables are set in A and two variables are set in B. Each variable is paired like this, so total 4 cases are carried out. In contrast, with the link option, there will be 2 cases because it is a one-to-one correspondence. And when using this option, there are some precautions. The item to be linked is designated with the same name, and the number of variables must be the same. So to use a link option, by entering the same number or a letter, they are linked to each other. Second, the number of variables that you enter in the condition must be the same. In this example, I will use the link option. Variable conditions for HTL and ETL thickness have already been set. Since I used the same variable condition, the number of variables is the same. Also, it should be entered as the same number or a letter for the link item. So I will enter letter A each. If so, under what conditions will the simulation proceed? By using the link option, it is one-to-one correspondence. Therefore, total 5 cases are simulated as follows. And the next layer is P.PSS. I will change the thickness. The thickness is 30 nanometers, so I will change it as 30. For other options, I will use the default setting. And the next layer is ITO. Also, I will change the thickness. It is 100 nanometers. So I will change it as 100. Lastly, there is a top glass layer. The thickness of the glass layer is 10,000 nanometers, and it should be set as an incoherent layer. So I will change the thickness as 10,000, and for the incoherent layer, you can change like this or change in the properties. like this. So I have set all the layer properties. Next, let's look at the output condition at the bottom. Conditions for output result data can be set. Observer side means results are output based on the observer. Set the theta and phi intervals. In this example, theta will be 10 degree step and phi will be 15 degree step. So I will change it as 15 degree step. And emission side means results are output based on the emitter. Specify the range of the in-plane wave vector. The smaller step of the in-plane wave vector, the slower simulation time. Therefore, it is recommended to use step 0.1. However, if you want to check dissipated power UKE and radiated power UK out, I recommend to use 0.001 step because they are graphs in which the x-axis is an in-plane wave vector. In this example, we will check the dissipated power UKE graph. So for the in-plane wave vector condition, I will change like this. And the next one is a wavelength condition used for the result output. In this example, it is set to 10 nanometer step, so I will change it as 10 nanometer step. Finally, if you check this internal field, distribution of E field and H field can be identified. However, in this example, we do not check it, so I will remain the default. Therefore, setting all of the simulation conditions is done. Please save the project and click Run button. When the calculation is completed, TechWiz OLED viewer will be run automatically. In the result panel, select the result to analyze. At first, model chart. Since this example doesn't define the color filter and multi-domain, there is no list to select in the cell and domain items. In the source type, select a specific light source to analyze. There are three types: external top, external bottom, and internal. Internal means the emitter. In this case, I just put the emitter of EML, so only internal is showed up. In the source, if more than two types of emitter are set, users can select a specific light source to analyze as well. In the data, select the item for the y-axis. In this case, I will choose mode efficiency. X-axis is literally for the x-axis item. I will select ETL thickness. In the variable, items set to variable appear. we applied multiple variables to the ETL and HTL thickness using link and variable functions. There is a one-to-one correspondence between ETL and HTL thickness. So HTL thickness item is changed to deactivate because we already select x-axis as ETL thickness. And also we entered 3 types of theta factor in the EML. So let's check the result by specifying the theta factor as variable. And then click plot. So, as I set the EML factor as variable, you can check each model chart graph according to the EML factor, like this. In addition, users can check 5-mode analysis in model chart: outcoupled, substrate, absorption loss, waveguide, evanescent. Let's see the meaning of each terms. Please look at this figure. Outcoupled means the ratio of the emitted light from the OLED device to the outside, and it is mainly designed to be high value. Substrate means the ratio at which light cannot be emitted to the outside by the substrate. Absorption loss means the light loss absorbed by the layers. Waveguide means the light cannot be emitted because of the difference of the refractive index between the layers. Lastly, evanescent mode means the light cannot be emitted because of the surface plasmon effect of the metal. To check the evanescent mode, in-plane wave vector should be set more than 1. Since the outcoupled value is designed to be large, it can be confirmed that the optimal design in this example is when the thickness of ETL and HTL is 40 nanometers. And let's check the control panel. In the data table, view the low data of the model chart. You can find the mean and max data. Also, enter a value and shade the values that match the condition. For example, if I enter 3 and select greater than and then click find, you can see that all values greater than 3 are shaded. The low data is compatible with the Excel program, so you can copy and paste it to the Excel file. Or just click the right mouse button and select Export CSV file. And the next one is label. Set the style of the model chart, such as color, style, and font size. And if you click Trace tool, you can see the mean and max data for each item. And by entering the x-axis value or moving the slide bar, you can check the y-axis value directly. In the axis, set the axis properties such as title or model chart style. And in the view control, set the various viewer options for the result. It would be helpful to check the viewer option in person. When you click the Reset button, rearrange the legend as a default setting, like this. So I have checked all of the model chart options. Let's move on to the Graph tab. Please click the Graph tab. From cell to source items, they are the same as model chart, so I will skip them. And there are a lot of things for the data, and it is for the x-axis. Other data results are irrelevant, but if you want to check the dissipated power UKE or radiated power UK out, please choose x-axis as normalized in plane wave vector. In this case, I will select dissipated power UKE for the data. And in the model chart result, the optimal design of this example is that ETL thickness is 40 nanometers. So I will set the ETL thickness as 40 and EML factor as variable. And then click plot. You can see the graph result. Let's check the control panel. In the data table, you can check the low data of the graph. In the graph, you can set the various line options and turn on and off the graph lines. For the label, axis, and trace tool, I already mentioned about them in the model chart, so I will skip them. The next one is the merge graph. Combine multiple graphs into one graph. I will show you a simple example. I will combine the two graphs by using a merge graph option. Choose the graphs to combine and then click merge. You can see the combined graph result. In this case, select axis can be utilized. If there are two or more graph data, it can be expressed by modifying the ranges of the top and right axis differently. When using this function, click axis and activate the right and top axis. I will enter like this. If the right and top axes are activated, two x-axis and two y-axis ranges can be input, so it can be easier to check two graphs at a glance. For example, let's set the range of the right axis from 0.1 to 0.3. And the range of the top axis is from 1 to 2. And then click apply. You can see that right and top axis items are added. After that, click Select Axis. And let's look at the first graph based on the right and top axis. And then click Apply. As you can check the result in different axis ranges for each graph, it can be used in various ways when analyzing the graphs. And the next one is a polar chart. From cell to source, they are the same as the model chart, so I will skip them. And there are 4 types of data. In this case, I will click Luminance. And for the wavelengths, I will change it as variable, and also for the EML factor, I will change it as variable. And for the ETL thickness and HTL thickness, I will change it as 40. And then click Plot. Therefore, you can check the polar chart according to the wavelengths and EML factor. The first option is cross-section theta phi. Extract the output cross-sectional data as a graph or a contour chart. Set the theta or phi angle by controlling the slide bar or entering the angle. For example, I will select phi and then move the slide bar like this. After that, check all variables and click Extract. The extracted graph is shown by user-defined angle. The next option is data extraction. Extract the data according to user-defined specific angles. Move the theta and phi angles, and then click Add button. And select the x-axis, for example, wavelengths. For the data set, please select all variables, and then click Extract. The wavelengths spectral luminance graph according to the EML factor and theta phi angle conditions is displayed. Also, you can check the low data in the data table and change the position for the displayed result in the viewpoint. In the data, the mean and max values are showed up. And in the view control, set the various viewer options for the polar chart. It is not difficult, so I recommend to click each option in person. Like this. And I will tell you how to modify the legend setting. For accurate data analysis, legend control is very important. If you change the legend, at first, please press this Delete All button and then edit the range. Just as an example, let's lower the end value. Since the max data is like this, so I will change the end value as also for the delta, I will change like this. After that, click OK button. You can see that the result is changed. Also, to change to the initial legend setting, just click Initialized and then click OK button. So by using the legend option, the user can set a specific range effectively to analyze. The other view options are very simple, so it would be better to check them by clicking directly. And the next one is a contour chart. Also, from cell to source, they are the same as the model chart, so I will skip them. And if you click the data, you can select the data for the displaying calculation result. In this case, I will click EQE. And for the x-axis, I will select ETL thickness. And for the y-axis, I will select EML factor. And then click plot. The result of a contour chart appears. In the data table, let's check the max value. As expected, it can be seen that the EQE value is the largest when the ETL thickness is 40 nanometers. This means that the tendency of a contour chart result is the same as the model chart, because when the ETL thickness is 40 nanometers, the outcoupled value is the largest. And if you click the data extraction, it is the same as the polar chart. Extract the data from a specific position and output as a graph. For the label and axis, I already mentioned about that, so I will skip them. In the data, you can also check the mean and max values. And in the View Control tab, it is also the same as the polar chart, so please check them in person. And finally, the Color tab is left. Actually, in this example, there is no color filter, so to verify this, let's add a color filter from the stack list, like this. In the layer DB, there is a color filter, so I will drag and drop it into the stack list. And please click Save As button. And then I will enter the file name and then click Save. After that, click Run button. Let's check the color result when the EML factor is 0 and ETL thickness is set as variable at the front. Click Plot. In the Set Color, set the color filter type. As I used the RGB color filter, click OK button. You can check the color result according to each ETL thickness. In the XYZ table, check the XYZ data for each color. In the data extraction, you can extract results such as color difference, color gamut, color temperature, and color contour. In the CIE table, it is linked with CIE coordinate, and it shows the coordinate values and gamut of RGB values. So if I change it, the information is also changed. In the RGB model, select the RGB model to display in the color result by clicking on and off. In the TechWiz OLED, there is a color tab for the CIE standard observer. The default setting is 2-degree observer. So, if you click here, the graph of tremulous values according to the wavelengths is shown as follows. And in the chromaticity diagram, the user can select the desired RGB model and CIE coordinates and check the result immediately. You can see that the reference coordinate information is also changed. The other options are very simple, so you can utilize it in person. Until now, I have confirmed the results by using variable and link options with a simple example.